Hello everyone! In this video, you will learn about an important concept and technique in unsupervised learning, clustering. Together, we will go through the idea of clustering with a simple example and some basic annotations. After watching this video, you will be able to explain the problem of clustering. So let's start with an engineering problem in practice. In our daily life, you might notice the quality of pavement when you are walking, biking, or driving. We have pavements in perfect conditions, with no cracks like shown on the left of this slide, and some damaged pavement with short or long cracks as shown in the right of the slide. Now, we have over 139,000 kilometers of roads in the Netherlands. Different vehicles drive on these roads on a daily basis, and this results in different and evolving pavement conditions across the country. Assuming we have a huge amount of images taken from the pavement, we call each image a data sample that we have. Using these data samples, we want a method that can tell us the different groups of data samples we have so that we can distinguish between pavements with no cracks, light cracks, severe cracks, like this. So how can we do this? First, let's learn a new concept. What is a feature? A feature is a real number extracted from the data samples we have. It describes a property or characteristics of the data sample. One or multiple features can be extracted from one data sample. For example, from the data samples of pavements we have, we can extract two features from each data sample, let's say x1 and x2. Here we have n data samples in total. So we have two features from every sample. The two features can be the number of cracks in the pavement, the maximum length of the crack, etc., depending on what features we extract the characteristic of the pavement quality. Now, let's find out what is the clustering using these features. We plot the features in a 2D feature space and get this figure. The horizontal axis represents the value of feature 1, x1, and the vertical axis represents feature 2, x2. Now, note that for this problem, we are given only the features, without understanding the physical meaning of the features or the ability to interpret the features into the pavement condition. In other words, we are dealing with an unsupervised learning problem. With only the features, what can we do to group the data samples into different groups as we want? So let's look at how the data samples are located in this feature space. We can notice that some samples are located close to each other, while other samples are located farther away from each other. Let's take this circle sample as an example. We can say this sample is similar to another sample located here. And this sample is dissimilar to another sample located a bit farther away. In this way, we can find more similar samples and dissimilar samples in the feature space. And here is where the idea of clustering emerged. The goal of clustering is to group similar samples into clusters purely from features. As an example, we can cluster the samples here into two clusters, C1 and C2. Note that it is also possible to cluster the samples into different and more clusters, depending on the clustering methods we use and the needs. We must understand that clustering is for us to explore patterns in data samples, because we are getting clusters purely from features without knowing the sources. The interpretation of the clusters still relies on further processing or human intervention or further analysis. In this video, we learn that clustering is the task of grouping similar samples into clusters. Clustering is done using one or multiple features extracted from data samples. And clustering is for exploratory purposes because the data samples are unlabeled. You may also notice that a measure of similarity or dissimilarity is needed for clustering. Thank you for watching this video.